So as we have already had the introduction about the program and its use cases and what would be you will be learning during this whole program. So proceeding further, today we'll have our day 2 and we will be moving further on the databases. Yesterday we have done a quick exercise in the end where we were seeing that how we can establish a quick database model, basically a physical schema. And today we will be proceeding further with the next set of topics. As we spoke about yesterday, the physical schema, and we have created one. Today we are going to talk about the database independence and what is the difference between a physical schema and logical schema in detail. How we can build an ER model, which stands for an entity relationship model. Okay, what are the different relationships we can build when we talk about the databases? What is an attribute and what is the difference between an attribute? Okay, what is the relationship? What is the generalization concept? How we can aggregate the data? What is the life cycle of a database development system? What is the database planning? How we are going to design the database? A few topics related to the database administrations also we will be having a quick look. So let's say apart from the development role, if you're exploring for any other role, that's going to help you as well. Then we have a concept of a fact. Fact is basically the actual information. So considering today we have the 14 participants in our session, that is an actual information. So that is the factual information which we are speaking about. And that would be the overall agenda for today. And during the end of the session, we will be working with one of the hands-on exercise as well, which is going to be included on how we are going to build an ER model, right? So that's the agenda for today. I hope everyone is set and recording is on. Soon, yesterday's and today's recording is going to get uploaded to our YouTube channel. The participants are going to get the links shortly by the end of the day. All right, so as you know, my name already, I had a long introduction yesterday, Sahil. I would be the prime instructor here during the next couple of weeks, which we have. And feel free to post your questions into the chat window. We have given one email as well yesterday. In case if you have any question, feel free to write your queries also on the same. All the materials is in the process of uploading to the particular server where you will be having access to it soon. All right, guys. So I'll not take much more time on the introductions, and now we are going to get started. We'll talk about first the database independence, or basically the DBMS data independence. So yesterday, if you remember, we spoke about the logical schema and the physical schema. And when I was discussing about the logical schema, we have decided that logical schema is the one where it's going to define the logical structure. So we first schema itself mean for a logical representation of a database. When we talk about the logical representation of the database, we really mean that how the different tables is going to be have a interlink or basically a relationship with each other. The physical schema is what we have developed yesterday in terms of defining the relation between the tables, creating the primary key, foreign key, etc. Now, when we talk about the data independence between a physical schema and the logical schema, what does it mean? Is that logical data independence can be defined as the immunity of the external schema to changes in the conceptual schema. Physical data independence, we stand as physical data independence can be defined as the immunity of the conceptual schema to changes in the internal schema. Now, what actually it means that when we talk about the logical data schema, right? Logical data independence. Let's say you have to change some logic in your way how you want to calculate your data. Okay, so those changes which you are applying on the logical rules, it can be rules in terms of, let's say, there is a table, and on that table you have created certain SQL queries, right? So consider that SQL queries, if you are making any changes into those queries, that's like your changes into the logical view of the data, how you are looking at the information. So that basically gives us the option that logical data independence, and we say that logical data independence can be defined as the immunity, that any changes in the logical schema immunity is going to not affect the physical dependence of the data. Okay. Now, when it comes to the physical data independence, similarly, we'll say that any physically when we are updating the data, let's say that I'm updating the data in a particular row for a particular column. Any changes which is going to happen at that physical data independence, it's not going to make any changes into the logical view of the information. So if you have written a query which uses two set of columns, okay, so any data change is not going to make any changes into the logical data, how you are viewing that information. So that is where we have this difference, and we will have to understand the difference between the data independence, because when you design a schema, when you design a structure, it is very much important that our schema is independent logically and physically from each other. Right, so that's where the concept of the BMS data independence comes into the picture. Then next, what we are going to talk about a very important concept, which is an ER model. So what is an ER model is basically ER basically stands for entity relationship. Now, what is an entity? So you have a table employee which is linked to another table department. So these are the two entities you have. Now you can see between the employee and the department table, we are defining the relationship based on the department ID. Okay. So in this case, what we needs to do is we need to understand that how this relationship between the two tables which we have, employee and the department, is going to define the whole characteristics of your database, right? So that is where when we talk about the ER model, we are basically talking about this all the relationships between the different entities what we have and why they are important. Because when you design a database, right, before you design a physical data model, you need to design an ER model. Okay, based on this ER model, you can understand that a table one, how it is linked to the table two, what would be the primary key and foreign key between the tables, what would be the flow of the direction of the data. All those things is going to be get decided with the help of an ER model. So here we can see that these arrows which we are representing, right, they are basically representing that the department ID in the employee table is a foreign key to the department ID into the department table. This PK basically stands for the primary key. FK here stands for the foreign key, right? So you can see that now again, employee ID is pointing to the employee table. So this is the primary key here. This is the primary key here. Okay, and this is a foreign key here. This is again the primary key. So the direction where we have these parallel pipes, right? That particular column is represented as a primary column in the table, and where we have this, arrow and the circle, this is basically is a representation of a foreign key. So this representation of the diagram, how we are having the tables linked to each other, is going to known as an ER model. ER model is really very important if you have to start your career in the field of database designing or SQL development or the database development. You should be very, very thorough about the ER modeling, because at any given point of time, you might have a source system. Okay, when I say source system, example, I'll give you the data. Okay, and in that data, you have the 10 different tables are there, and I would ask you to redesign the database. So if you have a knowledge of the ER modeling, looking at that source of information which has been provided to you, you can really remodel your database, and that is going to be done with the help of the ER modeling itself. So here, what type of relationships we can define, okay, how we are going to choose the right entity. This is what we are going to study further as a part of the today exercise. So as we say, ER diagram is a pictorial representation of the data that describes how data is communicated and related to each other. Any object such as entities, attributes of an entity, sets of relationships, and other attributes of relationship can be characterized with the help of the ER diagram that we are representing here. All right. So our exercise going to be for the today is that we will be working on this ER model with the help of a particular tool, which is going to be the diagrams.net, and there we will be developing this particular exercise. Okay. So now moving further, first we need to understand what is an entity. Okay. First we need to understand what is an entity. So entity is basically and how we are going to represent an entity when we are developing a database model. Each entity type is shown as a rectangle labeled with the name of entity, which is usually a singular now. So consider in a layman language or in a simple language, if you have to understand you, basically an entity is equivalent to your table name what you have. Okay, so here, if I'll come to my previous slide, you will see I have here total 4 entities. One of them is employee. Then we have a department entity. Then we have an employee skill entity, and then we have a skill entity, right? So these 4 entities is going to be represented with the help of a rectangular structure that we are talking here, right? So we have a staff and the branch entity in this particular diagram, what we are representing. Then a relation, because 2 entities, right? A staff and branch is going to have a relation with each other. Okay. Similarly, an employee and department will have a relation with each other. Employee and a skill have a relation with each other. Okay. And so considering the type of relation which we are going to develop, right, that is going to be understand with the help of the relation type which we have. So what we are saying here is we are saying that a relation type is a set of associations between one or more practicing participating entity types. Each relationship type is given a name that describes its function. Here is a diagram showing how relationships are formed in a database. So one thing to understand now, if you will see, we are saying that each employee is going to link to a department. So we can say that employee has a department, right? So this particular relationship, that how the relationship is going to go from employee to the department, is basically what relationship type is describing. So we are saying that staff has a branch, or sorry, we are going to read like this: branch has a staff. So that is where we are saying that when we have to describe the direction of the relation also, that is going to be described the type of relationship we are choosing. So we are saying that each branch has a staff. So similarly here we are saying that each employee has a department. Okay. So that is where the relationship types are also important when we are talking about the ER diagram. Now, what are the attributes? So we are clear about the relationships. We are clear about the entity. Now, the third factor which comes is an attribute. So what is an attribute? Basically, attributes are the property of the entities that represented using the ellipse shaped figure. What does that mean is, here, if you look at this particular first structure which I've represented, right? Here, how many attributes I have? In the employee table, I have 4 attributes. In the department, sorry, in the employee table, I have 5 attributes. In the department table, I have 4. 3 attributes. In the employee skill, I have the 3 attributes, and the skill table, I have the 2 attributes. So the attributes are basically the properties of an entity table, because when you talk about an entity as a whole, it needs to present certain information, and how it is going to present that certain information, it is going to present the certain information when it is having its attributes. So an employee can be represented with the employee names like first name, last name, then email, the departments, right? Similarly, department is going to be represented with the department name, phone number, description, etc. So each entity is going to have an certain attribute. So here in this case, we are seeing that student as an entity is having the 3 further attributes. And when it comes to the ER diagram, we are going to represent the attributes with the help of this ellipse shaped figure. So any chance in life, if you have to develop an ER model, you first need to describe your entities. Entities is basically equivalent to the table names what you have. And from there, that what you need to do is you need to describe the attributes of that particular entity. All right. So here now it comes that relationship. Okay. Now what is a relationship and how we are proceeding further? So let me open a pane here to help you understand. So first, what we have done is we have an entity which is represented in form of a rectangular shape, and this entity I will call as an employee entity. Now, this employee entity will further have, let's say, three attributes: one, two, three. Okay. It will have employee, I would say, name, then age, and then I have a department. Okay. Now, at the same time, there is another entity which I'm calling as the department entity. This department entity will have further attributes to it. Let's say department name and department phone number. I'll call it as a department name, and then I'll have a department phone number. Right now, if I will look at these two entities, I can easily say that they can have a relationship between them. And the way they're going to have a relationship is based on the department. So here, if I will say this particular set of columns can have a relationship with each other, right? So, okay. Okay. Now, department from the employee table is going to link to the department name from the department's table, right? So in this scenario, what we can do is we can say that department and the employee table is going to have a relationship with each other based on the department column what we have. Now, relation when we will say that each employee has a department. Okay. If I want, I can put up here the relation is the has. Okay. Now, type of relation is very important. Why is the type of relation is very important? Because one employee can belong to one department or one employee can belong to multiple departments. That is basically the crux when you design your ER model, because based on this, let's say if I will ask you, I have an employee named Sahil. And how many departments Sahil can belong to? Sahil can belong to one department only, right? Then there is another employee, let's say Raj. How many departments this Raj can belong to? One. So this basically showcases that one employee can be part of one department. So based on this data, when we are going to define this relationship, right, we will say that yes, we can have the relationship between these two tables, but the cardinality, okay, the cardinality, which is basically the relationship is going to be one to one, meaning one to one. That describes that one employee can only link to one department. Okay, one employee cannot link to the multiple department. So based on this cardinality, the flow of the direction of the data is also going to get decided. Plus, when you have to join the tables, when you have to define the relationships also, this is going to help you. All right. Now, what are the different type of relationships what we have and what is the cardinality? Let's discuss about it. So if you will see, when we talk about the relationships, right, we will say that there are basically four type of cardinality. So cardinality is the information in which using which we can define the type of relation between the two tables. When I will say there is a one-to-one cardinality or one-to-one relationship, meaning between the two tables, let's say employee and department, one employee record is only going to belong to the one department. Okay. Then if I will say the cardinality is between one to many, meaning one record from the employee can belong to the multiple departments or multiple departments can belong to the one employee or multiple departments, one department can belong to the multiple employees. Are you getting the difference here? If I would say, let me create certain set of a data here. So I would say that I have a departments table. And in that department table, as I said, we can have multiple departments, right? Let's say there is a human resource department. Then there is a administrator department. Then there is there is a finance department. Okay. There is the operations department, etc. All right. So now these different departments can belongs to the multiple set of employees, right? In human resource department, we can have 10 employees. In the administrator department, I can have 5 employees. In the finance department, I can have 15 employees. In the operations department, I can have 100 employees. So what this showcase that one department can belongs to the multiple set of records, but one employee is going to belong to the one department only. Okay. So what this showcase that when I will now, if I'll create an employee table here, employee table, let's say Sahil, employee name is Sahil, then we have Raj, we have Amit, we have Sumit, we have Suresh, Ramesh, etc. So Sahil belongs to finance department, Raj belongs to admin department, Amit belongs to finance, Sumit belongs to HR, Suresh also belongs to HR, Ramesh belongs to operations. So this showcase that each employee individually is linked to one department only, but multiple departments, the same department can be linked to the multiple employees. So in this case, when we have to decide the cardinality between these two tables, it would be 1 to n, meaning one record of the employee table, one record if the employee table can have the links between the multiple values. So here that we will have, sorry, it is going to be 1 to n. That one department can belongs to the multiple employees. So the cardinality what we are building here is, it in this case, it has become 1 to n is the cardinality, right? So earlier we were discussing about the concept of 1 to 1, that each employee was only belongs to one department and there was no repetition into the department. But in this case, what we are saying is that departments are being repeated and the employees can link to the multiple employees can link to the same department. So that is where the cardinality or the relationship type what we have is now, it is basically 1 to n is the cardinality which we are specifying. Okay. So this is very, very important when you describe a relationship, when you describe an ER model. If your cardinality has been created correctly, your relationship is going to also provide correctly. Okay. Then one to many or many to one, I would consider it is the same way, because you are just reading the data from the different direction. So here, when I will specify 1 to n, I'm reading the data from the department to employee. If I will start reading this information from employee to the department, then I will say many to one, right? So one to many or many to one, both are the same cardinality. What we have depends on how we are reading the data from what particular direction. And then the last what we have is we have many to many. So what is the example of a many to many cardinality is, let's say there is a certain employee which is going to have a certain skill set. So one employee can have a multiple skill set, and similarly, multiple skill set can be linked to the multiple employees. So that becomes your cardinality of many to many. So example, let's say I have an employee table where I have employee name. So this is the employee table, and in the employee table, I have employee name. Name can be Sahil, Raj, Ramesh, Suresh, Ajay, Amit, etc. Okay. And then I have another table which I am calling as a skill set table. So as a part of the skill set table, we will be having the multiple skills. Skills, let's say someone is having skills of database, someone is having skills of SQL, then Python, Java, ETL, etc. So here, what can happen is one employee can belong to one employee can be linked to multiple skills, right? Similarly, if I will ask the another employee can also link to the multiple skills. So this what we have now is this is the concept of the many to many, that many employees can link to the many skill sets. So in this case, when we come across this kind of a scenario where we have the cardinality which is defined as end to end, then it follows into this particular direction. Generally, when we work with the many to many cardinality, we will be using the help of something called a bridge tables. What is a bridge table? Why it is important? It will come into the subsequent sessions. But at this moment, if you come across this kind of a data set where one multiple values belongs to the multiple target values, that comes into the category of the many to many cardinality. All right. So this is where we need to understand how the different set of relationship is going to work. Okay. Moving further, the next thing what we have is a concept of generalization, right? So as a part of generalization, we will say that the concept of generalization, specialization is associated with special type of entities known as superclasses and subclasses in the process of attribute inheritance. Database managers begin this section by defining what superclass and subclasses are and by examining superclass subclass relationship. The ER model has the capability of articulating database entities in a conceptual hierarchical manner. Okay. So see, in short, if I have to make you understand the layman's language, when you deal with the hierarchical sort of the data, right, where let's say, if you look at this example, these are the three different type of fish categories we are representing. Let's say there is a livestock, you have the data, and in one of the livestock, you have the category of the product as the fish. The fish can have the further subcategories, which is shark, whale, dolphin, multiple other type of the fishes can be there. So this kind of the data when you deal with, right, this is basically more of a hierarchical information which we are presenting. And when we come across this is we will push them as a concept of a generalization. So instead of I'm having the three different columns or the three different attributes for the same information, I'm creating a subcategory here where the same value belongs to the different columns instead of creating the instead of creating the separate attributes there. So this is basically known as the concept of generalization when we deal with this kind of a hierarchical data. All right, then the next what we have as a concept of aggregation. So a relationship represents a connection between two entities that are conceptually at the same level. Sometimes you want to model the has a is a or is a part of relationship in which one entity represents a larger entity, the whole, and that will consist of a smaller entities, the parts. This spatial kind of relationship is termed as an aggregation. Aggregation does not change the meaning of navigating and routing across the relationship between the whole and its part. Okay, so here are the couple of terms first which we need to understand. When we talk about the ER modeling, right, what we have is as a part of the ER model, as I said, there are the rectangles are there are ellipses are there, okay. There is a diamonds are there and there is the lines are there. Then we have attributes, then we have, key attribute, composite attributes, etc. Okay. Now, when it comes to our relationship types, okay. So earlier we have seen this relationships right here, where we were talking about relationship has. Okay. So similar to the relationship has, we have the another types of the relationship, which is relationship has, okay, is a, okay, and then we have the parts. This basically represents the participation of the relationship on the data set, right? So in this scenario, what we are talking about is that how the relationship, the right, is going to different, how we can aggregate our relationship when we come across this kind of a data. So we will simplify the relationship with the help of the combining the different entities together. So instead of we are saying that teacher has a subject, okay, or teacher is a faculty, or teacher is a non-teaching staff, or teacher has a faculty. What we will do is we are going to aggregate their dependency together. So in this case, what we are finding is we are saying that teacher is an entity where everything is revolving around it. So teacher as an entity, when it follows the different tables, we will use this particular rectangle diamond. The purpose of this particular diamond, what we are representing here is the purpose of the what we are calling about a diamond is it represents the relationship among the entities. Okay. So now when we have to define the relationship between the two entities, it is going to be represented with the help of this diamond what we have. So we'll say that real teacher is going to follow the syllabus. So this has been represented with the diamond. Then now when we have our teacher is linked to the two entities at the time. So instead of using a diamond, what we are using is we are using it here triangle we are using. So in this case, instead of separating this teacher has a faculty or teacher has a non-teaching staff, we are so calling is it. So this basically representation of the ER diagram when we have to simplify it and when we have to make sure that the data is the ER model is being aggregated together. That's where the concept of aggregation comes into the picture. So that's why we are saying sometimes you want to model has a as a is a or is a part of a relationship. So that is where instead of using a has a and separating these, calling this as a one single entity, we have separated this as a two different entities and link the teacher to the thing. The next, what we are having is we are talking about the database system development lifecycle. So as a part of this database system lifecycle, what we are saying is we are saying that as a database system is the primary element of the more extensive organization-wide information system. The database system development lifecycle is inherently connected with the lifecycle of the information system. There are the different stages on which database is going to be developed. Okay. See, today, if you have to develop a database, right, you cannot just start doing the development. You need to first do a planning. Then once your planning phase is done, then you need to do the analysis. Once your analysis is done, then you need to do the logical design. Then you will do the physical design. Then the implementation of that physical design will happen, and then the database will go to the maintenance. So what are these different six phases of the database development life cycle we have, or we can call it as the DSDLC. So how we have a software development life cycle, right? Similarly, we have a database development life cycle also. What is the planning phase? Let's say I am a new customer who has come up with the problem statement to a particular organization or to an individual, and they're into the field of retail, and they are looking to the business is running, or they are a new business which is coming to the picture, and they are looking to now store all the information or a new software they have bought in, right? So when you have bought in a new software, you need to understand how the data is going to store into that system. And as a part of that, first you are going to do a planning phase where you need to understand the business of the particular organization, because whatever the implementations we are going to do, it is going to happen for a particular business in terms of any organization, any manufacturing industry, any school, college, anything. Basically for a set of business or for the set of individuals who is combined together representing a business. Okay. So first, when you analyze a business, that goes as a part of your planning phase, that what we are implementing. Now, in the planning phase itself, when you start analyzing their system, when you look into the system and start finding out the information, start finding out that whatever the different entities you have, what kind of a different data set you have, right? That goes as a part of the analysis system. From the analysis system, what we have is, then we will talk about the logical design. In terms of a logical design, then we start developing our ER model. We start identifying that how many tables we are going to have, what kind of columns they will have. Now, okay, and based on that, logical diagram is going to be presented. Once a logical diagram has been presented, from there on, we will move to the physical design. In the physical design, how we have created the physical schema yesterday, by specifying the actual table names, their data types, the use case of the data in which we is going to be created, the primary key foreign key relationship between the different tables is going to come into the picture, and that's where the physical design is going to be created. Once we have the physical design ready, then we will take the scripts of the database and start doing the implementation on the data which we have selected. So let's say that we have selected the database of Oracle, SQL Server, Snowflake. So whatever the physical design has been approved and created, then it's going to be implemented on the particular set of database. Once the implementation has been done and our system is live, after that, if let's say you have to make any changes into your system, so that goes as a part of the maintenance phase, where all the different planning, analysis, logical design, physical design is going to get repeated, and the maintenance will happen. So maintenance comes as a part of, we are going to do the small changes into the system as and when it is required. That goes as a part of our maintenance category, right? So that is where a database management lifecycle system goes through the 6 different phases before it will start finally going to the live. Right, so here we are explaining the different stages of the database development. First is a database planning. As a part of the database planning, what we are saying is database planning must be integrated with the overall system strategy of the organization. There are 3 main issues involved in formulating an IS strategies, which are identification of enterprise plans and goals with the subsequent proposal of information systems requirement, evaluation of current information system to find out existing strength and weaknesses, appraisal of IT opportunities that might yield aggressive advantage. 3 things very important. Let's understand. So first of all, when we say IS basically stands for the information system. So here first what we are saying is, we are saying that identification of enterprise plan. So this database development, what we are talking, right? We are discussing from the perspective of a large enterprise or a medium enterprise or a small scale enterprise, basically from the enterprise perspective. So enterprise can have the different meaning. Let's say an organization who is just into an IT company, an organization who's into the manufacturing, or any organization who's into the retail sector, anything, different kind of organizations can be there. Now, when it comes to the enterprise, right, as an enterprise, what we will say is there is going to be, what is the plan of the enterprise when they are implementing the certain systems? Okay, so identification of those plans is the first thing. Let's say I went to an organization and they want to give me a project, and as a part of that project, they're saying that, after 1 year, we want to migrate our systems to the, from Oracle to the Snowflake. So there I have a clarity of the enterprising plan. There I have a clarity that why they want to migrate, because they want to consolidate the information from the different source systems what they have. And that is where this whole, database migration is happening. Okay, so and then we need to be assured about the subsequent information systems in which the information is live. So if you have the multiple systems available as a part of an organization, but if we are not clear about the all the systems requirement, then that can be one of the issue which you will face. Then evaluation of the current system, because before you are, let's say, doing any new system, or before that you are creating any new migration system, you need to understand how is the current system is and how it is behaving. So current system in terms of, let's say, current system will have, five different set of data sources. One is a flat file, one is the Excel file, one is the XML data, anything. So you need to understand that these five systems which I have, which system is strong, which system is weak. Okay, what is the weakness of these systems which we have? What is the strength of these systems which we have? And how they can be migrated and how they can be interlinked with each other. So that is where the evaluation of current information systems comes into the picture. Then the last what we have is appraisal of IT opportunities that might yield aggressive advantage. So if there are multiple IT opportunities are there, and to transfer this database planning into the actual implementation also can become one of the challenge which we have. Then the second what we have is the database design, right? So when we design a database after the planning, what we do is we decide the process in which multiple enterprise mission statements and the objective comes, okay? And we have basically the two approaches to do the database designing, a bottom approach and a top-down approach. So what does it mean is, if I have to explain you here, first is a bottom-up approach. So bottom approach is where from the bottom, we are designing the system. What does it mean is, first, I'm going to look into the data sources which is at the bottom. Okay. Then we are going to look at the data source which is after this, then after this, and after. So this basically approach is known as the bottom up approach, where we are moving towards the end goal from the starting of the point. Okay. Then the second approach what we have is a top down approach. So in the top-down approach, what happens is we know that what is our end goal. So let's say in the end, I want to have one consolidated system. Okay. Now, as a part of this consolidated system, we are going to figure out the information required from the bottom system. So this is known as our top-down approach. So now which one is good, which one is better? That clearly depends on what use case we are dealing with. In the top-down approach, we already know our end goal, and now the time is to figure out the information which is available at the end. In case of a bottom-up approach, we already know about the source system we have, and on top of that, we are developing a solution. So the disadvantage of a top-down approach is you're clear about what do you need, but you're not clear about what is the source systems you have. In the bottom-up approach, it becomes a vice versa. You're clear about what source systems you have, but you're not clear about what is your final output you are required. So based on your requirement, you have to choose one of the approach, which either it's going to be a top-down approach or either it is going to be a bottom-up approach. These particular approaches are very useful and meaningful when we do the database development, especially when we do our data warehouse development. So what is a data warehouse? What is DWH? We'll talk about in the subsequent session. As of now, you need to understand that these particular two database design approach. But yes, so as I mentioned, the bottom-up approach starts with the fundamental level of attributes, which thorough analysis of the associations between attributes are clustered into relationships that signifies type of entities and the relationship between entities which we have. So as I said, right, all the underlying sources, how they are linked to each other, whatever the different type of entities we have, they're all going to be described with the help of this particular bottom-up approach which we have. And with the help of those identifying the relationships, we are going to look forward for the final goal. Now, when we talk about the top-down approach, it becomes the vice versa. In the top-down approach, we are going to first look towards the end goal, what we have, and then we are going to map it towards the different type of entities which is available as a part of our underlying source system and their relationships. Now, as a part of the database planning, once we have designed the database, now the task which comes is about the database administration. Why it is important to have an understanding about the database administration also, because when we talk about the databases, right, typically the DBMS systems, it goes through the different life cycle. Database planning, database analysis, database design, implementation, operate and maintenance, growth and change. So when the database goes from here to here, right, during the maintenance and during the growth phase, let's say the prime purpose of database is to store the information, to handle the kind of changes which we have into the data. So when the data is growing, it's required to go through a maintenance as well. Considering, let's say today your database size is 100 gigabyte. Okay. To store certain information of 100 gigabytes, you need a certain hardware also to be available. Okay. You need a particular your storage system on which 100 gigabyte worth of database can be stored as well. After next year, you know that now your data is growing to grow to 1 terabyte. So you need that particular storage. As that storage is not initially available, you need to add more storage devices to that. So that is where the database administration comes into the picture, which is going to maintain the overall health of the database, which is going to ensure that any changes which is happening in terms of taking the backup of the databases, in terms of maintaining any information at the databases, all those things is going to be done with the help of the database itself. So that becomes a very important factor, comes under the category of the database administration, right? So what we are saying here is a database typically provides various utilities for aiding database administration. That includes utility for loading data into the respective database and monitoring the database. The utility allows system monitoring, gives information on the query and the execution strategy. The role of DBA is the one who is going to fine tune the data and provide the different result sets about the data, going to how we are going to store the data, storage devices. And if a table has grown to the level where it needs to be split into the multiple tables, that is all going to be done with the help of DBA into the consideration. So the that is where the database administration comes into the picture, right? So anyone, any questions so far, please feel free to raise your hand or put me into the chat window before we will move through the next step. All right. So as part of the last topic which we have is about the fact finding. Now, what is a fact? Okay, it becomes more relevant when you have to deal with the analysis, right? So consider, let's say you are in a database developer, right? And you have developed and stored the certain information. As a part of that information which you have stored, you want to find some meaningful insights about the data. Finding that meaningful insight is going to be dependent on that what facts we are dealing with. In terms of facts is basically, let's say that you have to find out the information about how many employees belongs to an organization and how much revenue they are generating. So employee here is a constant information, department is a constant information, but revenue is an actual information which we have. Okay, as an actual information in terms of it is a metric information which is going to be changing again the period of time, right? So this basically set of the data goes into the category of the metric value, and that is stored into a special type of tables which is known as a fact table. So when we're dealing with the data, right, we need to understand about how we are going to find the fact. We are going to find the fact from the data by asking the questions to the data. Okay, by doing the research on the data, by observing the behavior of the data, by interviewing the different people and finding the information from there. So what we will talk about the fact finding is, it is the formal process of using techniques such as interviews and questions to collect facts about the system's requirement and preferences terms as the fact finding. So let's say that if I have to find an information, I need to find the information by looking into the different systems. I need to find the information by talking to the system owner. So let's say that I own an application which has been developed by me end to end. If a third person needs to know any information, they have to look into the documentation and they have to talk to me to find that information. So that is where we talk about this process of fact finding as the formal process of using the techniques by interviewing and asking the questions. Then the second step is when a database developer might use a fact finding technique and what type of facts needs to be captured. We represent an overview of how these facts needs to be generated and documented throughout the database lifecycle. Okay. A database developer commonly use several fact-finding techniques during a single database project, which is like examining the documentation, interviewing, observing the enterprise action plan, research, and questionnaire. So as a part of the database development lifecycle, when you develop the different type of tables, when you develop a database, you go through the certain set of questions and the techniques which falls into the category of fact finding. Here you will do the documentation, you will look into the documentation, you will talk to the different people, which is goes into the interviewing category. You will understand the overall plan of the organization. You will do your own research and the questionnaire before you will finally do the database development. That is basically known as our fact finding, right? So and that is where now we will see why do we need the database to the point where we are talking about the database development lifecycle. So as a part of this particular topic which we have done, we have understood that why do we need the relationships? What are the different cardinality of the relationships, which is very, very important when you have to move further and develop your databases. And from this perspective, we will be now looking towards how we are going to develop the ER model using a